In today's lab, we're going to be looking at measuring the mineral content in a canned food product, and we're going to do that by using atomic absorption spectrometry. We call it AA for short. Atomic absorption spectrometry is a very efficient method. It's a relatively quick method. There's not a lot of sample prep usually involved, depending on what type of product we're testing. You'll see how much is involved for a food sample here today. It's a very reliable method. It's very efficient. We can do a lot of samples in generally a short period of time. The instrument itself to purchase initially, of course, can be quite costly, but once it's in place, it can be a very effective and efficient method for measuring mineral contents in foods. It can measure elements and minerals and other elements down to the part per billion level, so it's a very sensitive method as well for trace element analysis. So today we're going to be specifically looking at iron content in a canned food product. So I have a canned soup product here, and you can see that I have the label covered up for confidentiality reasons, but you will be provided with the information on the product from the label. And one of the reasons why we're using canned soup in particular is because it does have iron indicated on the label. Okay, so it tells us what percentage of iron is present in the soup product. So we're going to compare the values that we receive for iron content using the AA method to the value on the label. Okay? So if you're following along with your laboratory procedure, we're actually going to be doing part 2 of the lab today. That's the non-ashing method. So we can do an ashing method where we actually burn or incinerate the sample prior to analysis, and a non-ashing method. So today we're going to be looking at the non-ashing method. So we're going to start off with our sample analysis. So we're going to take our sample right here, our canned soup. First thing we're going to do is get a weight. Okay, so we're going to measure it can and all on the scale and record that weight. And the reason why we're doing it with the can on is because we may not be able to get all the contents of the can out of the can and into our blender. So we want to be able to get the weight with the can, and then we'll subtract the weight of the empty can afterwards. Okay? So we record that weight. Now we're going to take our soup and we're going to dump it into this blender jar. Okay? And I'm going to take some water, and I've already measured out 100 milliliters of water here. I'm just going to use that to rinse out the inside of the can, just to try to get out as much as we can. So when that's done, then I'm going to weigh the empty can, and I'll have a more precise weight of what's in our actual blender. Okay. So now we want to blend the sample, so we want to make it homogeneous, so we need to blend it up. So we're going to put it in a blender here, and we're going to blend it until it is homogeneous. Once that's done, we'll take the cover off. Pour some out into a beaker. See that it is all mixed fairly well there. It's homogeneous. So now I'm going to take aliquots of my soup sample and divide it up into Erlenmeyer flasks. So we're going to do this in triplicate. So we have 3 Erlenmeyer flasks labeled ABC. So we're going to measure our sample out directly into the Erlenmeyer flask. So we want 10 grams of sample. Okay. 10 grams of each one. Now it doesn't have to be exactly 10 grams, as long as we record the exact weights. So 10.1, 10.01 is fine. So we put that one aside, we record the weight, and then we'll do the same thing with sample B. Okay, so now that we've weighed out our sample, we have 3 replicates of the same sample, the soup sample. To each one, we're going to add 20 milliliters of deionized water. Okay, so 20 mils to each one. And we're also going to add 5 milliliters of concentrated hydrochloric acid to each one. And we're going to do that in the fume hood. So I'm going to take these over to the fume hood to add the concentrated HCl. Okay, so I've taken our flask over to the fume hood. There's 20 milliliters of water in each one. And now I'm going to add 5 milliliters of hydrochloric acid to each one. Okay, so now we're going to put them on the hot plate to boil. So we're going to put them on the hot plate, all 3 of them can fit at the same time. We're going to bring them to a boil and then let them boil for 1 minute. Okay, so they've been boiling for 1 minute, so I'm going to turn off the hot plate. I'm going to take them off and let them cool down a little bit. Okay, so now that the samples have cooled off, we're going to transfer it from the Erlenmeyer flask to a volumetric flask. So we're just diluting it basically, and then we'll top it up to the line. So I'm pouring it into the volumetric. And we want to use a little bit of distilled water, not too much because we don't want to risk going over the line, but just enough to rinse out our flask. And then we'll rinse the funnel. And then we'll top it up to the line. And we're just going to mix that. And then we're going to filter it through some regular fluted filter paper. And it will filter very slowly. However, the good news is we don't need all of it to necessarily filter through. We only need about 10 milliliters or so, enough to do our sample analysis on the AAA. So we can just leave that and let that filter through until we get to about 10 milliliters, and then we'll use that to analyze on the atomic absorption unit. So we'll do the same thing for the other 2 samples, and then we'll move on to the AAA itself. This is the atomic absorption spectrophotometer. This is the AA7000 model made by Shimadzu. So I just want to show you the instrument and point out some of its main components. So the first thing we need to know is how to get the sample into the instrument. So the sample enters via the sample tube right here. This is very delicate, so you want to be very careful when handling it. So we simply take our flask containing our sample or our standard, and we gently place the tube in the sample under the surface of the water, and by capillary action it is taken up into the instrument. So the sample enters the nebulizer, which vaporizes the liquid. It evaporates off the solvent, and then the atoms enter the flame. So under this shield right here, which is there for safety reasons, you'll see a burner. So if we move in closer on the machine, this is the burner head. Okay, so that's where the flame will come out when we actually light it. So when we light it, I'll come back and show you what the flame looks like. This burner is adjustable as well. We can adjust it using the software on the computer, okay, to make sure it's in the right position. So that's where the sample enters through the sample tube, goes through the nebulizer where it's vaporized, so our solvent would evaporate off, and then our sample or our standard with the elements that we're interested in would enter the flame. In the flame, the atoms are excited, and when they drop back to the ground state, they emit light. Okay? So we have lamps in this unit. Come over here on this side, there's a little door, and that's where our hollow cathode tubes are. So we have these lamps for every element that we're going to test. So if we're testing iron, for example, we would have a hollow cathode tube lamp specific for iron. So these hollow cathode tubes contain the element that we're interested in, and it emits radiation at the same wavelength as the light of the element that we're interested in. So we have these specific for each element that we're looking for. So if you look closer, you can see this one is for zinc, and we have various different ones depending on which element we're analyzing. Okay, and you can purchase these for pretty much all of the metals that we're going to be interested in. So the flame for this piece of equipment is supplied by gases. So we have acetylene and air over here. Okay, so that supplies the fuel to ignite the flame. And everything else on the instrument is controlled via computer. So we have a computer over here that we use to set up the machine, so it contains AA software that we can use to set all the parameters that we need for our sample analysis. So now we're going to go over to the computer and get our machine set up and ready to run our iron standards and samples. So the software for the atomic absorption unit is pre-installed on the computer that's attached to the unit. So it's this icon right here. It's called AA Wizard with 2 A's. So when we're ready to start, we just click on the image of the instrument itself. We've set the login just to admin with no password. And then our software will open up. So the nice thing about this software is it has a wizard that takes us through the entire setup. It gives us lots of messages and things to check as we go through, so it's really straightforward and fairly user-friendly. So the first thing we want to do is choose which element we are going to be analyzing. So element selection, I highlight that, and then it opens up our wizard. So first thing we're going to do is select element. So you can see over here on the left it has a drop-down menu that has pretty much all of the metals in the periodic table that we can test using this piece of equipment. Today we're looking at iron, so we will choose the symbol for iron, and this screen gives us all of the default parameters that are preset for iron. So things like the wavelength, the slit width for the burner, the lamp information, the burner information, the gas flow rates, all of that's there. The defaults are preset, so we don't need to worry about changing anything there. So we'll hit OK. So we've selected our element. You can see right here it says iron flame, ready to go. Gives you the wavelength as well. Then we're going to select edit parameters, and that's where we're going to put in the rest of the information about our method. So this is where we would be able to change any of that default settings that I showed you previously for the iron lamp. That's all preset. We generally don't need to change any of these parameters for our purposes, so we'll leave that as is. And we'll just go through the rest of the tabs. This one is for ACS, which is an auto sampler. We don't actually have an auto sampler attached to this piece of equipment, so we can ignore that. Under repeat measurement conditions, so this is where we're telling it what we want it to do when it takes a measurement. So it gives a number of repetitions for each sample that we're going to analyze. So if we do a blank, if we do standards, if we do a sample, that's generally what we're doing in this lab. So what we're going to do is change each of those to 3. So we want the machine to take 3 measurements for each solution that we test. Okay, so we want to change that to 3, and you'll see what I mean by 3 measurements when we get into actually doing the analysis. So we'll change those. Under measurement parameters, so this repetition sequence refers to what the machine actually does when it takes a measurement. So we have 2 options. We have S and M is for spray and measure. So spray, measure, measure, measure means that with 1 spray into the machine, it will take 3 consecutive measurements from that same sample. We could do the opposite, which would be to take a spray and then a measure and then another spray and then measure and so on. Okay, we want it to do 3 measurements on 1 spray, so we're going to change that to spray, measure, measure, measure. Everything else stays the same. Under our calibration curve parameters, this is where we're going to set up our units for our calibration curve, so the standards that we pre-made. And our units in this case are in parts per million, ppm. Okay, we can choose whether we want to set a 0 intercept or not. We're going to leave that for now. And that is the only things that we need to change here in this software. There are other places where you can put in comments about your procedure. You can put in weight correction factors if you have weight dilution factors or volume dilution factors. You can put that in there. For our purposes, we're not going to use any of that today. So this is all we're going to do here. So we'll hit OK. And next. Okay, so now we're going to be able to set up our calibration curve. So this machine does a calibration curve for us automatically, which is lovely. But we have to tell it what our standards are. Okay, so we've already set the units, so that's already there in ppm. We're going to tell it down here on the bottom under measurement sequence for calibration curve how many standards we have. So we had 5 standards. Okay, so you can see now it added a line down here. And we're also going to tell it the value of our standard, so what the actual concentration is in ppms. So we're going to change that to 1, because remember our standards were 1, 2, 3, 4, and 5 ppm. So we're going to change these to match up with what our standards are. And this will vary depending on what standards you actually use. So if you make up different concentrations, you can enter in whatever you actually use. Okay? So we've told the machine what our standards are, what the concentration of those standards are, so it's going to use that when it calculates the calibration curve. So we're going to say OK to that. There's also a section for sample setup, so we can tell it how many samples we want to run. And again, we can put in weight correction factors up here, but we're not going to bother with that. We will tell it what the units are, so the units for our samples we want to be the same as our standards, so we'll change that to ppm. And in this lab we ran 3 samples. Okay, so we're going to update that, and you'll notice that our sample table then changes to just 3 lines. And we have the ability here to put in names for our samples or sample IDs if we want to. Since we only have 3, we labeled them ABC. We're just going to leave them as they are. Okay. We'll select OK. And next. So we're just going through step by step. Okay, now that we've put all that information in, now we're going to send that information to the machine. So by hitting Connect Send Parameters, it transfers that information to the actual instrument. So I've already turned the instrument on, and I've turned on the gases, the gas tanks that are connected to it that supply the fuel. Okay, so that's already done. So now we have a pop-up that's doing a series of initialization checks. Okay, so it goes through a series of checks. You'll notice that there are a couple here that are giving us white circles, which means no test, not connected. And that's because This one is the auto sampler that I already mentioned we don't have, so there is no auto sampler to check. The other one, GFA, that's the graphite furnace. Okay, we also don't have a graphite furnace. This AA is just flame. Okay, so those are fine. We'll let it go through the rest of the checks. So now we're getting a pop-up for gas adjustment. So it wants to check the gases to make sure that the fuel supply is okay. So it's asking us to turn on the ventilation system. So that's the fume hood above the atomic absorption unit. So that's already on. So now it wants to purge the acetylene. So we just hit that. And if you were here in the lab, you could hear a hissing sound that the gas is being purged. It actually wants us to do that 5 times. Okay, do it again. Okay, so I skipped ahead because it takes a little while, but it has been done 5 times now. All right, so now we're going to purge the air supply. So that one purges for 10 seconds. Just checking our airflow. You'll notice this one down here, number 3, N2O. We're not using that gas here today. It's not connected. So we can ignore that one. We don't need to purge it. Okay, done. Hit close. Now it wants to check us to check a few things. So it's asking us to check the burner sensor, the drain sensor, and the support gas pressure monitor. So we can check all of those here on the actual machine. So I'll check all of those. I've already done that, and I'll select yes. Okay, so now it wants us to do a drain sensor. So I'll just go to machine there now and show you the drain sensor. Okay, so back on the machine, if we lift up the flame guard here, this little panel actually comes off. Just put that aside. And you should be able to see now a little plastic bottle inside the machine. That's where our drain sensor is located. So if I take off that cover, you'll see that inside there is the drain sensor. So it wants to make sure that that is working properly. So it wants us to lift it over the surface of the water and hit OK. And then we put it back under the surface of the water, screw it back on, and then it'll ask us to check that the drain sensor is below the surface of the water, and we hit OK in the machine as well. So there's a couple different things we have to manually do there. The other thing that's important in this step is that this bottle is full of water. So we just fill it up with deionized water, and we can tell it's full because when it's full, we'll see some of the water pour out of the overflow here. Okay. Now, this drain sensor, it's also connected to a tube here that goes down to a hazardous waste bottle. Okay, and that collects all of the waste that comes out of the machine. So excess solvent and anything else that's there that comes out as waste, so it doesn't go into the environment and we can dispose of it properly. Okay, so that's the drain sensor. So back at our software, here we get the message, lift the drain sensor over the surface of the water. So I do that, I hit OK, and now it wants us to move the drain sensor below the surface of the water. And say OK. Please supply air. So it's checking the OK button after we supply air, so make sure the air is on. It is, so we hit OK. You notice again there's the N2O check, which we are not using. So we'll say no, we don't wish to check it. Okay, now it's going to check the fuel gas pressure. Say check it. It's telling us to make sure that the acetylene gas is on, which it is. We'll hit OK. All right, we got a green light there. And now it's going to start a leak check. Okay, so a leak check takes about 8 minutes, so that'll run in the background while we can finish setting everything up. All right, so that's running. We'll hit OK. Now it has a series of instrument checks that we can do. So we're checking the fuel and the support gas, checking that our cylinders don't have any leaks, so we've already done that. We're checking the gas supply pressure, we've already done that as well. We're checking that the burner slot is not clogged, so we want to physically look at the burner, make sure there's nothing in there that could be obstructing the flame. Make sure that the burner head is firmly sitting in its port. We're checking that the nebulizer is attached to the chamber, so we're doing physical checks on all of these things. Make sure the end of that drain tube is in the container, it's not in the water. Okay, so we want the drain tube to be above the surface of the water. That's that hazardous waste jug that I showed you. Making sure the front panel is on, so remember we had to take that off to check the drain sensor. Set the chimney, so that's the portion that covers the flame. And emergency stop. We'll check all of those things and then say OK. Now it's sending the information to the machine again, setting the parameters. All right, next. We'll hit next again. Okay, so now it wants to do a line search and a beam balance. So this is a mandatory step. So we'll say OK. It does it automatically. It takes about 5 minutes. So we're still waiting for our leak check to run as well. So we'll wait for this too. So what this does is it checks the wavelengths, makes sure that everything is lined up between the burner and the lamps, and it does these checks automatically. So we'll let this one run. Okay, so our line search and beam balance are done. We've got OK on both of those. So we can close that window. All right, and that was the last step. So this just shows us our gas flow rates. We'll hit finish. And now we're ready to start our analysis. So on this screen, you can see that up here, it tells us what element we're analyzing. So we're looking for iron. And this is the absorbance that will be measured when we do a sample. So you'll see this change when we enter actual sample in the machine. Down here, we have our table that gives us all of our standards and the concentration, and it also has our 3 unknown samples in there as well. One thing we're going to do as well is add a blank. So if we hit blank right here, you'll notice it puts in a section for a blank. So we're going to run a blank of distilled water before we start our standards. And then we'll start with the lowest standard and work our way up. You'll notice down here on the bottom, GLC, that's our gas leak check. Okay, so it's still checking, and it says no ignition for 4 minutes. So that means we can't light the flame yet. It won't allow you to light the flame until the gas leak check is done. So after 4 minutes, then we can light the flame. So we will wait for that to finish. You also notice here we have a few sections up above. So this section right here, that's where our absorbance, so you can see it says ABS, that's for absorbance on the left-hand side there. That's where our actual absorbance will plot, so we'll be able to see where it comes out when we actually do a sample. And over here, this is where our calibration curve will be displayed. So we have concentration versus absorbance. So we put in our standard concentrations of 1, 2, 3, 4, 5. So we'll see those points show up there, and it'll plot our calibration curve for us. Now our gas leak check is finally done. So no gas leak is detected. Good news. So now we're ready to ignite the flame. So we'll hit OK, and we'll go ignite the flame. Okay, so our leak check is done. Every other test has been checked. We're ready to light the flame. So to light the flame, we hold in on the green and gray button at the same time until our flame ignites. And we can hear it ignite. Okay. So it has a safety shield covering it, but if I lift it up, you can see we have a nice clean flame there. So the flame should be mainly blue. We'll see little flickers of orange there, so it should be nice, clean, hot flame. So now that our flame has been lit, we're ready to start our analysis. So the first thing we're going to do is auto zero the machine. So we'll see how up here we have some numbers. We want that to be 0. So we'll hit auto 0. And that should set that back to 0. It will fluctuate a little bit, but it'll be fairly close to 0. And now we can start by running our blank. So we're going to put some distilled water in there and use that as our blank. Okay, so you can see it added a blank right here. Once the blank is done, then we're going to start with our standards. We always work lowest to highest, so we'll start with 1 ppm and work our way up to 5 ppm. Okay, so you see when it turns back to green, start button, then we're ready to start. Okay, so we're going to take our sample and put it in the machine. So just holding it in the tube, as I showed you. And you'll see pretty quickly, if I scroll back up, that the number up here is changing. Okay, so that's increasing as our iron standard is being taken up by the machine. So now we're going to hit start down here. And what it's doing now is taking those 3 measurements that we set it up to take. So remember we did spray, measure, measure, measure. So it's spraying the sample into the machine and taking 3 measurements. And as I mentioned in the intro to this lab, it's a pretty quick technique. Once everything is set up, you can see it's already done that first measurement. So that took a matter of seconds to give us 3 readings, and it automatically calculated the average for us. So you see we have 3 readings here. So it did those 3 measurements, and then it gave us an average right here. Actually, I'll scroll up, you can see the 3. There we go. So we have 3 readings, and it gave us the average of those readings. Okay. So now we're just going to run through and do all of our consecutive standards. So our next standard is 2 ppm, and you can see I'm just holding it under the sample tube so that it's taken up by the nebulizer. And if I open this carefully, you can actually see the color change in the flame as the elements are entering the flame. So we hold this in position, and then we hit start on the machine. So we're going to hit start. And you can see over here on our graph, this is just raw data graph, but you can see the jump in absorbance, and that's expected because we just doubled our concentration, so went from 1 to 2. And again, it's taking 3 measurements and giving us an average. So here we are. So this was our 2 ppm. You can see that the machine took 3 readings and gave us an average. And it also starts, now that we have 2 points, to plot our calibration curve. So here's our line so far. So you have a perfect straight line so far because we only have 2 points. So here's our 1 ppm, there's our 2 ppm. And you can see it also gives us the equation for the line and the R² value. So right now it's at 1, of course, because we only have 2. We want that to stay as close to 1 as possible. So let's run the rest of the standards, and then we'll come back and look at the graph again. So our standards are all done, and you can see we have our calibration curve now is complete with our 5 points. We look at our R values, 0.9984, that's not bad. Okay, so we have a pretty good standard calibration curve that we can use for determining the results of our unknown standards. So now when we do our sample, we put our sample on the machine, same way we did with the standards. So we have the solution that we made up earlier. We can just put it under the surface of the water, exactly the same thing that we did with our standards. You can see the difference in the color of the flame there. And then again, we just hit start on our software. And then we hit start. And because we set it to 3, same as we did for the standards, to do 3 replicates, it's again going to do 3 and give us the average. There we go. And now we're going to run the next sample. Again, got it on the machine. We'll press start. And our 3 readings are done. So if you look at the data table down here, based on our calibration curve and based on the absorbance, it gives us a calculation for concentration. So you can do this the same if you've likely done in other labs by just calculating it from the equation. But this machine actually does it for you. So that's nice as well. So it's telling us that it's about 0.7 for a concentration for that unknown sample. If we scroll up, we'll see the other one was 0.8811 and 0.8568. So they're relatively close to each other, okay, because remember they were the same sample. Okay, so that's it for the software. Now that we're done with that, we're just going to extinguish the flame, and then we're done with the atomic absorption unit. So when we're all finished, we just press the extinguish button. The flame will go out. Okay. Then we just turn off our gases, turn off the machine, and we are done. Well, thanks for tuning in. I hope you enjoyed it. I'll see you in the next lab.